Hello, my name is Nicolas Charles. I'm a co-founder of Rudder, and I'm already sure that by now you know that I am French. I apologize about the accent. I would start by a question. If it works, okay. It's stuck. Okay, are we really looking at the logs of our config management? Do we really know what it outputs? I knew a startup who implemented their infrastructure using configuration management. They did everything by the book. It was very awesome. Every time a new machine had to be provisioned, it had to go through configuration management. Every changes they made was through configuration management. Perfect. And at some point, they had a big success, and they had to grow, like big grow. And their infrastructure started to fail. It was very surprising because everything was in success. All the reports were green. And it turned out all the reports were green except on one machine. They forgot to centralize the logs of one of their systems, which was failing after some modifications they made in their code. And so when they had to spawn a new machine like this one, the machine didn't work, the infrastructure failed. Okay. They could fix it, and now they are very successful, and it's very cool for them. But at this moment, it was very surprising. And if we don't have errors in our log, does it really mean that we have success? Can't we miss something? If everything is green, does it really mean that everything should work as expected? In a previous work, we were doing, in previous job, we were doing open source software support. And we had one customer who had a big issue with the single sign-on. Nobody could log in anymore on their system. And when I say nobody, I mean 50,000 people. So it was a very big issue for them. We knew they had an upgrade on their LDAP clusters a few days ago. And the update went well. It was done manually, but the operator said it was okay. And all the logs from what they did was okay. So we thought that maybe it was in the single sign-on, there was an issue. Maybe they put some bad information in the LDAP, etc. We went through everything with them, and we couldn't find easily the cause of their problem. So what we did is we looked back again at the logs of the installation. Okay, it was all green. And we do a detailed inventory of each of the machines of the cluster because we noticed there was something wrong in their network. So sometimes packets were lost on the networks. Maybe there was something wrong, something bad on the cluster. And it turned out that on the 16 node clusters, there was one package that was different from the others. And it was because the operators, when they did their upgraded everything on 15 nodes and forgot one on the 16th node. It was a very small error, very subtle, and it prevented everybody from working during one day, one full day, 50,000 people. Do you imagine the cost of that? And there were no errors when they did the upgrade. Understanding the outputs of any commands or of config management softwares especially is very hard. How do you know? How do you get the information you need? How do you understand what's getting outside of your config management tool? An operator needs very detailed information. An API needs something that's understandable by a computer. a manager will need a KPI and nothing more. If we have to translate all this information all the information that comes out of the config management software to a language that can understand each of the parties manually, we will have a lot of frustration. If an administrator needs to make reporting every day to its manager to prove that everything is okay, the administrator will probably get mad, and the manager will probably think that they are wasting money to do that. They will probably want to change the solution because the admin don't want to spend time changing, reporting, changing, transforming data for somebody else, or even worse, for an API. And the manager will think that he is wasting the company money by having to do some transformation. Some errors can be very bad. Like, for instance, the OpenLDAP cluster issue is terrible. And it was even worse because there were no errors. Errors in production can have very big impact, but sometimes it's not a big deal. You can expect some errors in production, especially during upgrades. You are upgrading something and the dependency fails because you are doing a change in production. It's okay if it's for a short period of time and you know that it should fail, okay. On the virtual machine of the developer, it's also no big deal. But if you forget to upgrade your SSH during Heartbleed, for instance, it is catastrophic. If you need an expert to tell you what is the impact of an error, you will have a lot of problem in the long term. I don't know how many of you have ever been bothered by a colleague to understand if an error was really important or not. Who has been woke up during the night because there was an error with config management that was reported and the person on call didn't know if it was bad or not? Only you? Only? Okay, you are very... If there are only 2 persons in the room, then you are very lucky. Being woken up at night because somebody doesn't understand the impact of an issue is very frustrating, especially if it doesn't have any impact. It will wear you down, or it will wear down the expert if it's you who have to bother somebody else. And it's a single point of failure. There is a very famous social network, a professional social network, where one person was a conductor of their infrastructure. He was managing, he created all the architecture for configuration management for 50,000 servers. Now it's about 100,000 servers. And he was the only person able to understand the big picture of the configuration management. Everything at some point to go through him to change, to improve, or to do whatever. At some point, he was simply overwhelmed by the work. He go to the direction and say, that's too much, I want to quit. He was the guy in charge of 50,000 servers. The company tried to keep him inside, and it turned out he wanted to live by a lake and to have a nice view and to be happy. So what they did is they bought him a house by a lake and make sure that he always had electricity and internet available. So they dug 2 tracks and made 2 fibers channel to the house by the lake. And now he's managing more than 100,000 machines in this social network. To know the exact state of the infrastructure, we have monitoring, which looks at the output of the system from outside. So you get to see if something goes down, if something is broken. It exposes the symptoms very quickly. So you can see when something is broken, but you cannot know why it's broken. It's like was said yesterday by Charity Majors, it's a low cardinality data. You can't dig in and see what's happening. You cannot, you have only correlation in monitoring, so you cannot see what caused what, or exactly, you're not sure exactly if it was after or before something due to network partitioning, or you don't know how fast events are spreading across your systems. On the other hand, observability gives you the ability to see what's inside your system. You have all the internal data, you have the context, you know what caused what, you have precedents. It's already widely used, observability, for databases. There are plenty of solutions, a large ecosystem of tooling to extract knowledge from your database and observe what's going on, what is bad, try to improve your queries and usage of databases. For software, it's starting to be a solved problem as well. For legacy software, you have plenty of agents you can embed in your virtual machine or interpreter or whatever that will automatically detect all the workflows, all the processes inside, and do reports so that you can observe what's going on. And when you are developing a new software, there are standards, there are architectural bricks that you can use for this observability. And what about configuration management? In Rudder, we tried to make observability and make information available to everyone the central point of Rudder. We are still a long way to go, but it's really the basic within Rudder. One thing that is important is everyone and everything can be an actor of configuration management. It can be operators, it can be manager who will give directives to people to say, I want this like that, or it can be computers. Oh, sorry. Here it's an overview of the different components that makes a configuration within Rudder. I will go over the details here, but on the right-hand side, you have the nodes, which are the systems that are managed within Rudder. They have an inventories, so you can make groups of nodes, and everything else is what you will make, how you will make your configuration and apply it to your nodes. So first, the techniques. It's a set of operation and configuration to reach a state. So it's state-based. You have variables to configure these techniques, and they are created by experts of Rudder, or of the service you want to manage, or of the specific configuration you want to manage. We have a graphical editor to do that. Here it's a technique that's been created within the graphical editor. It's a technique to configure NTP. It has several states. We ensure that the package NTP is present. We configure the NTP service, and we restart if we change the configuration. And if we go to the detail, configuring NTP service is actually using a template, and that will be expanded. So an expert will know that we are basing our NTP configuration on a Jinja 2 template. Somebody less expert will have only the information that we are configuring it. We don't need to go more into the details. The directive is the application of these techniques. We take techniques, we put parameters in it, and it defines how this service will be configured or how this configuration will be made. It's driven by business, and it's managed either by administrators, operators, or via API or CMDB. You can get your data from a CMDB to fill in the blank in your technique. And finally, the rule is the application of one or several directives to one or several groups of nodes. It's the higher view of your services. It's again managed by admins and APIs. The reporting based on that is also adapted for each of the population. An operator will have console output with the information that the configuration is compliant. The security experts will need to know that a specific entry of the CIS benchmark is compliant or not. Here it's for RSH and talk. The manager will know that 100%. He doesn't need to know more. So, and the API will have a detailed information. It's completely compliant for a specific rule with an ID and a name, and the directive also are compliant. So we are exposing data in the format that each actor at stakes can understand. But what is compliance? This is the detailed view of Rudder, and it's internal. We have all the components I talk about, the parameters, the rules, the directives, the groups. They are the state we want to reach with Rudder on each of our system. It's historized, so we know at what moment what was the desired state on all the infrastructure. Then we have business people, more technical people, APIs that are changing these states. Each time they change something, we have an event log, so we know exactly who did what and why. And it gets historized also so that we can look back in time to see what happened and why it was done. And it creates a change request. Once the change request is validated either by a human or automatic process. And we have environmental data, schedule, type of configuration, external data from data sources, CMDB, information on nodes. Once it's validated, it creates configuration for the nodes. So Rudder will compute everything that should apply on the nodes. It will create an ID out of that so that we can track which configuration applied on which system. We have a timestamp. We know when it was done. We have also an expiration date, but we'll see that after. And it creates all the configuration files for every system. This is the second half of the graph. All these configurations are stored in a database. It's serialized, so we know for each node what is the desired state, the expected configuration, with an ID, a timestamp, and the end of validity. We know that this configuration is valid up to a certain point. If we regenerate new policies, the old ones are not valid anymore. It's not the state we want to reach. Agent will fetch the policy, read them, apply them, report. And each of these reports is actually sent to a database. It also sends metadata, the identification of the node, ID of the policy, when it was run also, and the signature of the system. All of this goes to an engine that will compare what was sent from the node and what was expected. So we can do the difference between both. And we know that if something is compliant, then it means that it was effectively a change that we wanted to be done on the system. If we receive reports that were not expected, we have a warning message that some reports are unexpected. And if a node didn't check some policies, we have missing reports. So we know that it was skipped, and we have to dig in to see why it was skipped. All of that gives us a compliance by node, by directive, by rule. We can plug this compliance through an API. We can execute scripts based on compliance changes or some values, and people can watch it, can see it. We have a lot of information available within Rudder, usable in the Rudder context. Everything is historized one way or another, most of the time within a PostgreSQL database. We know the detail of each run, the timestamp of each action each node did, the agent did on each node at each time. All the configuration are serialized. All the inventories are there. We know exactly the state of the system. We can also have the state of the systems over time, etc., etc. But it's available in the Rudder context. So we can probably do more than that and expose it more. Indeed, we need more information of causality and dependency. We need to be able, and it's not only Rudder, it's every configuration management software, needs to be able to expose why a change was made on the system, what was the cause, and what was the cause of this cause, to get to the root cause, to know which commit trigger which changes on which system. But why would we need this? We have the logs. We have experts that can dig in this log and spend time understanding. I'm sure you all know this show. This guy, Dr. House, has a lot of experts. They are all the best in their fields. Somehow they have unlimited resources to do any check on any patient, so they can spend, I don't know, millions of dollars doing checks on patient, and they still can't find the cause of issues at the beginning of the show. At the end, they all find it, but they never know, is it a symptom? Is it a cause? Or is it really the disease? Is it a side effect of the disease or of the current condition? And the only way, or nearly the only way they find the cause of the issue is to break into the house of the people and see where they live, what is their lifestyle, who they saw, what did they do. And it's often a very small thing that triggered the condition of the patient. Like a guy cut himself with a paper in his basement and has a locked-in syndrome. Somebody was stung by a bee because they had flowers and it gave them some kind of weird disease that nobody understands, etc., etc. And they have to check the past of the people, because the people were not able to know that this information were relevant. There are no way for normal people to know that when you cut yourself with a paper, it can be bad. Imagine how is it with an infrastructure. You have several teams working on many systems with a lot of interdependencies. How do you understand how can you find easily what is the cause of any actions? When you change something on one system, it can have impacts of hundreds of other systems. What's really important is to be able to separate the causes from the symptoms. With monitoring, you cannot do that. Monitoring gives you only correlation in time. So you know that two things happen in parallels, but you don't know if one is before the other or in the other way around. So there is no way to identify that, or to identify that something really happened because of something else. Only if you have causes and precedents, you can get to a root cause. How can we do that? It's awesome to be able to do root cause analysis easily. While there is event sourcing and tracing, which is not new, to be honest. It can help you trace all events across all your infrastructure. Every time something is done, it will trigger an event that will trigger another event with the context of the previous event. It will give you context on what's happening, and it can even track things happening in parallel. The terminology of open sourcing and event sourcing and tracing, based on data from Google and open tracing, which is starting to be the de facto standard of that, is you have traces. It's a kind of transaction that moves through a system. Transaction means an action that has a beginning and an end across several systems. It can be when you log in on Amazon, put things in your basket and buy it, but it can be also when you do a change across several systems because you are upgrading something. A span it's an operation. It has a name, it has a time, it has an ID also, and it's one part of a trace. It's putting something in your basket on Amazon is a span within a trace. Validating your basket is also a span. And then you have a span context. It's information about the trace that goes with the span. And it's very wide information. You have information about what started the trace, but you have also information about where the span is happening. Like if you are using a JVM, it will give you all the JVM configuration on which system it's running, the garbage collector used, the memory used, etc. And it's the same for any other languages. So what's in the span? In the span, you have an operation name. So it has to be relevant. So it's the job of the developers to put a real name for a span that can be understood. It has a start and an end timestamp, so you know exactly when it happened, and you can check exactly how long it took. And you have a set of key values that are the tags, and the set of key values that are the logs. The logs are what we usually do for logging, and tags are used to extend the information of these spans to add even more context or to restrict the usage of the span afterwards. And the span context, which is a link to the span of creating the machine, the virtual machine, the trace, and etc. This is a graph from Jaeger, which is a popular tracing library from Uber, if I'm correct. So what you have the time there and several traces. Here you have a trace that started another trace that contained two spans, one after the other, and then you have again another span that closes the first trace. A good something that helped me understand exactly what were trace and span was imagining it like HTML. You have a div, it's the trace, and the spans are effectively the span within a div. In the context of Rudder, what would be the traces? Defining the configuration state is a trace. People start doing changes on the state, like they change a directive parameter, it starts a trace. It makes spans. People are going back and forth, changing other parameters, refusing the change on a directive and doing another change on another one. And then when you validate the result and you commit them, it closes the trace. A new trace is when Rudder computes the configuration of nodes based on this global state. It will compute the targets, it will compute the overrides, policy overriding another, etc. Each of these steps of computation are spans also. When everything is available to the nodes and are serialized, your trace is finished. And then each time a node starts to apply policy, it starts a trace. It will do each of the checks on the system. Each of these checks will be a span. And when it sends the reports to the server, it closes the trace. This is a slightly modified version of the previous graph with event sourcing implemented. What will be Rudder with complete event sourcing. So it's basically the same graph with purplish stuff on top of them. So here, each time somebody do a change in row, directive, groups, or context, it's an event. And when it's validated, it closes a trace. So here we have a trace. Then the computation of the node configuration is also a trace with each of the steps. Agent running and doing any checks do a trace. So each of these reports, if each of these check will be a span, and sending the metadata, it will be simply the span context with the signature which is also the span context, and it will send back all the data to the run reports database. It will close the trace. Every time a trace is done and closed, it will send to a message bus. So configuring here is sent to the message bus. Each of the run of the agent goes to the message bus. The compliance computation also goes there. And you can export data to CMDB, to hooks, to monitoring, to the other database. But also it can get data from CMDB, get data from hooks, and from monitoring. The idea is that it goes both ways, and that you can feedback that again within Rudder to do something. There are many solutions for message bus, many solutions to store all this data. So the idea would be to integrate with systems that is already in place. So that would be optional. And it's true for Rudder, but it's true also for every other configuration management software. Many tools are compatible with open tracing. Many tools, we have many architectural breaks you can use. It can be Kafka, it can be Datadog, you name it. And it will allow you also to correlate with non-observable systems and to integrate with observable systems. So you have the two benefits out of that. So with Rudder, we centralize automatically all information and make it available in a way that is understandable for most actors or most things using configuration management. I would like to ask you a favor. Once the configuration management camp is finished, could you, before or once you get back to job, but before going back to your routine or day-to-day work, could you take a couple of hours to ponder on how you can improve your usage of configuration management? How could you make things better for you and your colleague? How can you more easily exchange information with them out of the configuration management? How can you store information in a better way that you can automatically process and feed it in monitoring? But if you have also a message bus to feed it into that, and how will it make your life better? It's something that I feel is very important because it improves the teamwork and it improves the quality of your configuration management and all of the other tools in the ecosystem that you are using. And once we have billions of events out of configuration management, what can we do out of them? What's the ultimate goal of having all these events? You can react on issues. You have a meltdown on your infrastructure. You can query all these events, search, analyze, and go back to the source of the problem and fix it more quickly than with simply monitoring. But I hope you won't have any kind of catastrophic issue like that. And you can have a more proactive approach and automatically detect what are the processes in your system. There is process mining, which is machine learning on these events that you can apply. It will automatically learn from the usage of configuration management and detect things that are unusual, that don't fit in the cattle. Outliers, things that are taking longer than usual. Maybe when you do a change on a group of nodes, all of the nodes are updated but one. It can maybe it will help you detect this kind of things that should not happen, or things that are happening but which are a bit fishy. It can help you also improve the overall quality of your configuration management usage. It will help you detect that you are doing a very circumvented usage of it, and you could maybe have a straighter line by exposing you all the workflow over all the systems. This is not something new. This is something that Mark Burgess was exploring 15 years ago already. He published a paper on anomaly detection in 2004, which was automatically detecting anomalies on systems based on the events of configuration management. And it was 15 years ago, so it's really nothing new. It was doing statistical differences and machine learning on the systems, on the events, to really see what was going wrong. And he went even a step further by saying that we could automatically fix it by implementing fail-safe in configuration management. So if something went wrong, it will automatically goes back to the normal by incorporating in advance proper countermeasure within the policies. I would like to thank him because he is always in advance on everything that's happening in configuration management. And it was when I was writing this this presentation, I discovered that I thought it was quite new, all this process mining, because I spoke with developers about the topic and they were saying, oh, it's pretty new, use the machine learning on that. And then I discovered that it was actually 15 years old in configuration management and that nobody's using it already, and that's probably a mistake. Do you have any questions? No? Yeah?
You are going to move Rudder into a direction where this is somehow built in or can expose data?
Yes. In the long term, we will expose more data in a structured fashion with all this context and all the trace, and etc. Yes?
Well, like, so far we only do that by looking at Rudder, and then I think if it's automatically, that would be much cooler. But even now, from my experience, if there's a system which is an outlier in any case, there has never been the whole time that we're looking So you can really trust these outliers blindly. You just don't have a working system which somehow shows up as an outlier. Any single one is a problem.
Okay. You never had outliers before?
Outliers?
Yeah.
Have always been caused by errors. So there was no false positives ever.
Okay. Great. Any other questions? Okay. I have some more minutes. So I have some extra slides. What about security? Because event sourcing and tracing everything expose a lot of data. It shows basically the ins and the outs of your infrastructure. So everything about your systems is sent to this message bus and stored somewhere, hopefully somewhere safe. How can you make sure that this information doesn't leak to unauthorized person? When you have a unique system, it's pretty simple. You have authorization, authentication, so it's fairly easy to do. When you have a distributed system, it gets much harder because you need to know who can see what, who can do what, which machine can write on which systems or send to which message bus. You probably have legal headaches as well because of compliance issues, but not compliance like configuration management compliance, but compliance like ISO or PCI DSS compliant. How can we do that? As I said earlier, you have tags on your spans, so you can use these tags for security and make sure that people can see only the logs or the events based on the tags that are on that and on security based on these tags. It doesn't solve all the issues. Most notably, it's very hard to cipher information and make it available partially to some people. So it's still an open question, the security of that, but it's something that I wanted to share with you as something important. And I don't have any more extra slides. Thank you.